So, next up we have Seth Vargo telling us a bit about modern secrets management with Vault. Enjoy.
Hi everyone, again. How's everyone doing this afternoon, morning? All right, I know I am standing between you and the restaurant. So, as you can tell by my body type, I'm not one to miss a meal. Yesterday, you saw a talk about the modern data center, and it was mostly slides. It was actually, to be exact, 164 slides. Today, I have 18 slides for you. That means you all get to go to lunch early, right? Well, no. Today's talk is primarily live demo based. So please all say a quick prayer to the demo gods, because after these 18 slides, I'm going to be jumping into a terminal, and everything here is off the cusp, on the fly, with a little bit of script in the background. But with that, let's go ahead and get started. I'm still Seth from yesterday. I still work at HashiCorp to the best of my knowledge. If you recall yesterday, we build tools that automate the modern data center so you can provision, secure, and run any infrastructure for any application. And today, I really want to focus on that secure component. And in order to talk about that, just like yesterday, how I took us kind of through a journey of the past, I want to do the same thing with security. And I want us to talk a little bit about a monolithic application, a traditional monolith, say 1995, early 2000s monolith application. You have all your code in one repository. It's probably Java, let's be honest. All your code is in one repository. It runs on a physical machine that's physically connected to the network with a network cable or a serial cable. And you do, your TLS termination happens at the F5 because someone convinced you to buy that. So your application doesn't really have to worry about TLS. And even more so, all the communication happens internally. So let's say this is like an online shopping cart. In a monolithic application, that app does the rendering of the web page. It handles every click that the user makes via the client-server relationship. It handles the order processing. It handles the credit card processing. Everything is self-contained. Everything lives within that monolithic application. There are no other services to talk to. The riskiest external connection you have might be resolving DNS. And additionally, it's in a physical data center, most likely. Again, we're talking mid-90s, early 2000s. So we're not running in a cloud environment. So we actually trust our data center. Maybe we're running in our own physical data center or a retail colo, but it's secure, there's physical security, and I have physical access to that box. I can walk into that box and put a padlock on the rack if I want to. And in this environment, security wasn't easy. It was just different. We had to think about physical security. We had to think about memory. We had to think about application vulnerabilities. Should an attacker be able to exploit code on our website and gain root access to the machine? And those vulnerabilities still exist today. But let's compare the monolithic architecture to a service-oriented architecture. So looks very similar. You still have a load balancer, and you still have some security rules instead of a firewall. But then you have multiple applications that have one very specific responsibility. So what problems does this introduce? Well, first of all, you're likely running on shared infrastructure. Cloud provider, or at least some type of virtualized infrastructure in your own data center. So you don't necessarily own the hardware that your code is executing on. You're relying on the cloud provider's load balancing, which might be at a software-defined layer instead of a hardware-defined layer. Internal and external requests exist. Not only are we routing traffic between our different microservices, between our different applications, but we also are communicating with third-party services like hosted databases or external DNS or whatever as a service. The root is that everything boils down to nothing is trusted. You don't trust the metal that you're running on. You don't trust the provider that you're running on. You don't trust the isolation layer you're running on, whether that's VMs or containers. You don't trust the traffic you're receiving. You don't trust the traffic you're sending. The only thing you trust is the code you wrote yourself. And because of that, every request requires authentication. We have to verify that incoming requests are actually valid. Is the person making this request able, are they authorized and authenticated to make this request and receive this data? Okay, I'm going to send a response. Am I sending the response to the correct person, to the correct machine? And most importantly, because there's so many of these applications and so many microservices and so many different components, there's a lack of a break glass procedure or expiration. And what do I mean by that? Well, if you imagine and you think about some of the high-profile security vulnerabilities and security leaks that have happened over the past couple of years, one of the biggest ones is probably a company by the name of Ashley Madison. How many people here have heard of Ashley Madison? Okay, so they created an arguably unethical service, and they were breached. And the challenge, if you read any of the white papers about the Ashley Madison story, is that they knew they were breached and couldn't stop it because they didn't have a safe and sane way to be able to revoke credentials. They didn't have a safe and sane way. They couldn't visualize the rollout effect of revoking a database credential or taking a server offline. And this is really important, that as your organization moves to cloud and moves to microservice-oriented architectures, that you identify these procedures. Can I take this server offline? What is the customer impact? If I take my front end offline, I can no longer process orders. If I take my back end offline, maybe I can continue queuing orders and then bring it back online and it'll continue processing with a slight delay. These are the types of questions you have to ask yourself as an architect, as a DevOps engineer, is what are the critical services and how can I resolve or return from failure? And what is the break glass procedure? If I get paged because there's some anomaly detection software that says, hey, we think there's an intruder in your network, they've gained SSH access into the Bastion host because someone leaked their SSH keys, what do you do? And how quickly can you resolve that? And the answer is not 3 seconds because I just pick up the phone and call the ops team. You have to actually think about these problems. And honestly, that's why we built Vault, is because it's really freaking hard. It's really hard, especially in large organizations, to try to understand the surface area. And it's really hard to generate credentials, to revoke them, and to give them expirations. Because traditional applications aren't built for passwords that expire. And I'll talk about that in a little bit. If you remember yesterday, we make a bunch of other tools. I already talked about them, but this is an obligatory slide. So what is Vault? Well, it's actually really complex to explain. Vault started as a not open source, never was going to be open source project internally at HashiCorp. We just crossed 100 employees, and our co-founder and CTO, Mitchell, sent an email out reminding everyone of how Vault came to be, and I had forgotten. We were a company of like 5 or 6 employees, and we had gotten together for kind of a hackathon. And at the time, we were working on a commercial product called Atlas for like a DevOps delivery workflow. And because of that tool, in order for it to work, the users would have to give us their cloud credentials. You would have to give us your AWS access keys, your Google account JSON, your API keys. And we needed a way to academically be able to say that those keys were secure. And yeah, we could use latest encryption algorithms, but we needed a way to prove to big enterprises that their data was safe, that other people couldn't read it, and that we had a very clear mitigation path. And it was literally impossible. The only way to do that is like spreadsheets on spreadsheets, or you build your own custom tooling. So we started designing a tool, and I, of all people, was like, this should be open source. And that was the inception of Vault back in 2014. Now, you might know a little bit about Vault's history in that it didn't become an open source project until 2015. And if you remember yesterday, I talked about dogfooding. We ran Vault internally for over a year, building features, making sure it was perfect, getting it audited by the NCC group, which is an independent auditing firm, security auditing firm, before we ever open sourced it. And since then, its scope has grown. Vault is a number of things. At its basis, it's an encrypted key value store, a distributed, highly available encrypted key value store. The easiest way to think about this is encrypted Redis or encrypted Memcache. Highly available, but encrypted in transit and at rest. But it's more than that, because instead of storing the data, Vault can encrypt the data and send it back to you. It doesn't store it. In this way, Vault acts as encryption as a service. So how is this any different than your application doing encryption? Well, your application, in order to do encryption, first of all, has to implement modern best security practices. You have to know all the different algorithms and all the different trade-offs between them. Your application also has to be aware of the encryption key, the symmetric encryption and decryption key, which means that if an attacker can gain access to your application, they could potentially read the memory of that application and get the encryption key out. By using Vault with encryption as a service, no applications have to understand any of the modern encryption. They make an HTTP or HTTPS call with the data they want, and they get back the encrypted data that they store. They then do the opposite of that to get back the plain text data should they ever need it. And this is advantageous because if an attacker was able to somehow gain root access of the application and download the entire database, they would still have to gain root access to Vault and somehow extract the key from memory, because it's never actually persisted to disk in plain text, to decrypt all of that data. So that's two things Vault does. It can both act as an encrypted secret store, or it can act as a pass-through or transit of secret data. But there are other tools that do that. That's not really exciting, and it doesn't actually solve the problem of what do I do when I've been breached? This helps with security. It helps make application developers adopt better security practices because it's easy. We lower the barrier to entry to encrypt data, but we haven't solved a problem yet. And this is where Vault separates itself from other tools on the market, both commercial and open source, is that Vault actually acts as a secret acquisition engine. In addition to storing credentials, Vault can communicate with a number of third-party providers to generate credentials. One of those is databases. Vault can communicate with Microsoft SQL, MySQL, MariaDB, Postgres, Cassandra, Rabbit, a number of databases or database-like services. Vault actually establishes a connection to those services, runs the command to generate users and passwords, and returns them to you. But unlike someone doing that on the console, they have a TTL, or a lifetime, in Vault. So how many people here are familiar with the way DHCP works? So when you connect to an access point or a network, your machine advertises its MAC address to a DHCP server, and the DHCP server looks at a pool of IP addresses and says, here, you can have this one, 192.168.5.33. It's good for 8 hours. At the end of 8 hours, it's your client's responsibility, your local laptop, your MacBook Pro, your Dell, your Surface, to then go back to the DHCP server and say, hey, I'm still using that IP address. Could I please have it for another 8 hours? And the DHCP server might say, sure, and then it just extends the lease. And it knows not to assign 533 to anyone else. If for some reason, though, you close your laptop, you go on vacation, you come back, that TTL has expired, and maybe the DHCP server has allocated that to someone else. So you'll go to the DHCP server and say, hey, can I have 533? And the DHCP server says, no, that's Joe's laptop, but you can have 547. And all of that happens transparently to you as the user. How many people knew that that's what happens whenever you open your laptop? Cool. Vault does the exact same thing, but instead of IP addresses, it's credentials. And instead of opening and closing your laptop, it's TTLs that are long-lived or short-lived, depending on your configuration. We'll look at some examples in this, but this is a really different way about thinking of credentials. Right now, in your organization, how do you create, say, a Postgres or a MySQL credential? Well, if you're a startup, you probably Google how to create Postgres credential. You go to Stack Overflow, and you copy some things into a terminal, and then you copy some things into a text file, and you're done. Perfect. And then you probably store that in your Chef server data, your Hyra data, or whatever your data store is, and you might encrypt it, and you walk away from it. And then 6 years from now, when you're breached, you have no idea why, because you haven't changed your database password in 6 years. On the flip side, though, if you're an enterprise, you probably file this thing called a JIRA ticket and wait 6 to 8 weeks for someone called a DBA to email you the password in plain text, which you then put in the text file of the application. But you might keep a copy locally, because that was so painful. Like, you don't want to go through that every time you need to connect to the database. So we'll just put that in the home directory. No one will notice, right? How many people have done that before? Yeah, exactly. Vault solves that problem, and I'll show you how. But what about things that aren't databases? a lot of people here are moving to cloud technologies, and I think it's very clear that our industry is moving in that direction. So I can't say definitively whether all applications will eventually run in the cloud, but I can say that most of them will. How do you generate cloud credentials, like Google account credentials or Amazon IAM access keys? You might use the CLI, but I think the majority of people go into the UI, click buttons, assign policy, and then they copy and paste things and email them to people. So let me ask you a question. If a new developer joins your team right now and they need access to the AWS console, how do you get them that access? Someone probably logs into the console and clicks buttons. With Vault, we've solved that. Developers can access their own IAM credentials via the API by logging in with GitHub or LDAP or their own username and password locally. Unlike Amazon, though, these IAM credentials have a lifetime. So you can say that IAM credentials that developers generate are valid for 5 minutes. That's enough time to run some commands locally, maybe spin up an instance. But if those get leaked out, you can't spin up enough Bitcoin mining servers in 5 minutes to actually do anything reasonable. So what else can Vault do? Well, more recently, we've been pushing the boundaries of Vault. And Vault can actually act as a full PKI internal replacement. Vault can act as a certificate authority. Why is this useful? Well, in microservice-oriented architectures where you trust nothing, how do you know that the application you're communicating with is authorized and authenticated to receive the data? If we're in a situation where someone is able to launch an instance inside your virtual network in Amazon, how many people here are authenticating those requests? If an attacker is able to make their way into your network, can they see the traffic between your services? So it's not just about authentication, but it's also about encryption. If someone can gain access to your network and they can see that all your communication between your microservices is done over non-TLS basic HTTP, you're not really protecting anything. So by adding TLS, we can protect external people from snooping on the traffic, but we can also apply client-side and server-side certificate verification to ensure that the clients talking to each other, the microservices talking to each other, are actually verified, are signed by the same certificate authority. And if anyone here has ever generated a PEM file for OpenSSL, you know that it's like this magical incantation of commands that, to be honest, I have never not copied from Stack Overflow. And if you ever generated X509 certificates, it's even harder, and then you just shove them on disk somewhere and hope that they never expire. And because that process is so convoluted, we typically give really long crills and really long expiration dates, like a year or 2 years or 5 years to these certificates, because we don't want to deal with it. With Vault, it's one API call. So internally, and in a number of our customers and users, we have certificates, TLS certificates, that have TTLs of 30 minutes or 5 minutes, and crills as low as 30 seconds. And then we continue to push the boundary even further, because in addition to being able to secure communication between services, we want to provide developers a way to actually gain access to running instances. So we know that if you're running immutable infrastructure, you should never do this. Developers or operators should never SSH into an instance. It's tainted, it's not a good practice, it's not a good security practice. However, sometimes it's a necessary evil. You have a service, you need to do some debugging, whatever. Traditionally, you use Chef or Puppet or Ansible or Salt to write out an authorized keys file with everyone's public key so that they can SSH in. Or you use a configuration management tool to manually create all of these users in the system. And then the challenge is when someone leaves the company, do you remove their SSH key from the authorized keys file? And the answer is usually no, or usually within 3 months. With Vault, we can authenticate users via LDAP, Active Directory, or even GitHub. So the moment that you remove someone from the company LDAP server, or the moment you remove someone from a particular team on GitHub, they lose SSH access. What's really advantageous, though, is that they're using their same private key and same public key that they use for Git pushes and connecting to their own personal servers. The way Vault's SSH CA authority works is they make a request to Vault to sign their public key and private key with Vault's certificate authority. And then the servers that they want to SSH into check against Vault. to make sure that the certificate, the SSH key that they're trying to access with has been signed by the CA. So we don't have to generate keys, we don't have to run any OpenSSL commands, it's just 2 API calls. And again, we continue to push the boundaries of what we think of secret management. How many people here know what TOTP is? Okay, so for those of you that don't know what TOTP is, I promise that you do. You've just never heard it called TOTP. TOTP is an algorithm for generating one-time passwords based on time. So it's time-based one-time passwords. So if you've ever used 2FA or MFA, you've seen TOTP. Vault can act as a TOTP generator. So it can replace something like Google Authenticator or Authy or Duo. But then again, and I promise I'm almost done with slides, we can push the boundary even further. How many people have ever tried to implement two-factor authentication in their own application? Is it easy? No. Is it easy to get it correct? Even harder. There are open source algorithms out there, and there are even client libraries that exist. Like there's a really popular library for Rails that'll do the whole thing for you, and it's still really hard. So wouldn't it be great if something did TOTP for you? You can delegate TOTP authentication to Vault. So in addition to Vault being able to replace something like Google Authenticator or Authy, it can also be the provider for those tokens and the validator on the other end. So you don't have to write a whole bunch of Ruby code or Python code or Node or Go to be able to do two-factor authentication in your application. You just make an API call. Everything in Vault is just an API call away. And I want to show you that now. So I have 38 minutes of demo. Here we go. Who's ready for this? All right, so we're going to go ahead and pray to the demo gods. Okay, we're starting out good. Type the password right. So this is a Vault cluster that I have set up in advance. It's really easy to install Vault, though. You download the binary, move it into path, and start the server. 3 steps, really challenging. So what I'm going to, is this a good font size for everyone? Wow, it's really quiet. Is this a good font size for everyone? Perfect, all right. So what I'm going to do here is I'm going to check the status or status of Vault, depending on where you come from. So I'm going to run Vault status, and this is going to tell me a little bit about the Vault server. This is an unauthenticated API endpoint. So your load balancer or your health checking service can hit this without being authenticated to Vault. And there's no sensitive information in here except maybe like the version of Vault that you're running. So this tells me that I'm running Vault 0.7.2. I happen to be running the enterprise build here, but that's irrelevant. I have a cluster name, a cluster ID, which is a UUID, and some things called key shares and key thresholds. We'll talk about those later. Like most applications, though, I have to authenticate before I can do pretty much anything. So I'm going to go ahead and authenticate to Vault, and I'm going to authenticate as this user that I created in advance called root. Normally, when you authenticate to Vault, you have like really long UUIDs, but I didn't feel like copying and pasting, and I wrote a lot of Vault, so I cheated by using something called development mode, which allows me to very quickly spin up a Vault server. Let me show you what that looks like. So this is back on my local laptop here. I would like a Vault server to test something. Vault server -dev. I have a Vault server. Pretty crazy. How many people have ever tried to run a service locally, and you're like, config file, and this other thing, and then this flag. Nope. Across all of the HashiCorp tools, we're adopting the dev mode. And what dev mode is best practices, ready to go, hit the ground running to play around with the service. So this is a Vault server on my local laptop with one command. I'll quit that. So that's what I'm doing on this server here. And I've configured that server in advance to cheat a little bit with this demo. I'm also trying to prove to you that I'm a real engineer, so it's a little bit of imposter syndrome. So I've authenticated to Vault, and that's cool. But now what do I do? Well, I'm going to kind of go with the same order that I introduced some of the features to you. And the first feature I talked about was the static key value store. Again, think of this as like encrypted Redis, encrypted memcache, but it's highly available, globally distributed, just like Consul's key value store. And I can do that by just writing data. And before I do this, it's not going to feel secure. You're not going to feel insecure unless you already do feel insecure, but you're not going to feel secure. So I'm going to run this command, vault write secret foo a equals b, and the data was written. And I'm going to read that data back out, vault read secret foo, and I get the data back out, a equals b, along with this other thing called a refresh interval, which I'll talk about in a second. How many people feel more secure now? Yeah, it doesn't feel secure. And that's because as an industry, we have been conditioned to believe that security has to be hard. Yes, I will say that again. You have been brainwashed into believing that security has to be hard, and I will tell you what I mean. When we were looking at Vault before we built our own, we evaluated a number of popular open source and commercial solutions. And one of those solutions, which I will not name, is a really nice web UI with clicky buttons. I think it's like Ember or React, so it's really cool. Server client model, has really great ACLs, policies, permissions. Really cool. It is so hard to use that the web UI never actually displays the plain text value. You copy and paste this like encoded value, and then you run their CLI locally to decode that value into plain text, which is not really friendly to someone who's non-technical. So we're looking, we're digging, we're like, oh, how does this work? What is the encoding? And it turns out, very long story short, that process, that service, that application, which again I will not name, stores all of the data in one file on disk. It is not encrypted, and it's in JSON. So all policy and enforcement happens client-side in the React or Ember or whatever front-end JavaScript framework they were using. Additionally, that obfuscation, not even encryption, it was just obfuscation upon further investigation, all happens on the client side. And then here's the real kicker. Anyone with half a brain can open up like the web inspector in Chrome or Firefox, see the AJAX request to the raw JSON file, which is just served directly by the server, and get all passwords and usernames and credentials in plain text. And we actually talked to a company who was using this, and we talked to the developers, and we're like, you know this happens, yes? And they said, shh, don't tell the security team. It's how we get access to things. I kid you not. But the tool felt so secure because you had to run some commands and it felt secure. But as an industry, we've been brainwashed. We've been brainwashed to believe that security has to be hard, and it doesn't. And Vault proves that. Vault has been audited by the NCC group over 5 times now, which is a very reputable independent security consulting firm. The first time, they found a few vulnerabilities, we fixed it. The second time, no vulnerabilities. Since then, the only vulnerabilities that have been found in Vault have been very, very minute. They register low on the severity scale, and they're things like timing attacks, where we're not using a constant string comparison. So a very skilled attacker might be able to guess the length of a password. And we always fix them in a very timely manner. Vault is also open source, so you're free to audit it on your own. Back to the demo. So I wrote some static secrets. I can also list some static secrets, if I can type. Vault list secret. And we can see that I have a key foo in there. So this is your basic create, read, update, delete, list key value store. Again, very similar to Redis, very similar to Memcached. The data is stored, but it's encrypted, in transit, and at rest. So I'm going to go ahead and delete this key. And now you can see that I have no keys in secret. Again, probably don't feel secure, but I promise it is. This one's actually extra secure because there's no data ever persisted. It's all running in memory. But Vault has multiple storage backends. So now I want to talk about semi-static secrets, or where Vault acts as the encryption as a service. And with Vault, everything is based off of kind of like file system mounts in a way. So here are the default mounts. We're already looking at secret slash. That's where data is just stored in transit and at rest. There's cubbyhole, which we won't talk about here today. And then there's sys, which is like internal config, like an actual sys mount. So in order to do the encryption as a service, I have to mount the Vault backend. And I do that by issuing the Vault mount command. So I'm going to go ahead and mount the transit backend. And this is now available at the path transit. Everything in Vault is path-based. Vault is an HTTP API server. So when I write to secret /star, that gets delegated to the secret backend. When I write to transit /star, that gets delegated to the transit backend. When I write to sys /star, that gets delegated to the sys backend. And when I write to banana /bar, that gets routed to, oh, no backend, 404, backend doesn't exist. So we can go ahead and run Vault mounts again, and you'll see that the transit backend is now mounted. Most backends have to be configured before use. And that makes sense, especially when you start talking about communicating with databases. So the transit backend is, you can think of it as like a collection of encryption keys and decryption keys. So in order to use it, I have to first make a key. But I don't have to run any like special commands. I can just create a key. So I'm going to write to transit key is my key. And I have now created an encryption key. It was that easy. I didn't have to run any special command or copy and paste anything from Stack Overflow. I just made a key. And I don't actually know what that key is. Because unless I explicitly allow Vault to return the encryption key to me, Vault will never divulge it. There's no way to get it back. It's only stored internally. So now, let me encrypt some data. So I'm going to write to transit keys my key, because remember, I just created a key named my key. The name of the key is just like a human-friendly pointer, almost like a symlink to the key. As we'll talk about in a little bit, it's actually a symlink to a ring of keys, because Vault will do encryption and upgraded encryption on those keys. Now, one of the things that's a little bit weird about the transit backend is that the data we pass in has to be base64 encoded. Does anyone have an idea of why we might require people implementing this to encode their data in base64? Anyone? You have 3 seconds. Close. Very close. It's not the URL, it's the payload. Everything in Vault is a JSON API, so we're going to be sending a JSON payload up to this Vault server. And there's no guarantee that the data you're encrypting is representable as ASCII characters. For example, I could be encrypting a PDF or an image or a binary file right now. So in order to safely transport that as text, we have to base64 encode it. So I'm just going to cheat, and I'm going to use the coolest thing that every time I show people this, they're really excited. Did you know that you don't have to pipe echo something? You can just use three less thans. This is my favorite bash syntax hack ever. So what this does is I spawned a subshell to base64 encode foo, which is the same as echo foo pipe base64. So that's what I passed in as the plain text. That data was returned to us, maybe. Transit. Oh, I wrote to the wrong endpoint. Whoops. Transit encrypt plain text equals. This is why demos are hard. There we go. That data is returned to us as ciphertext. So this is the encrypted data. Vault did not store any of this. It is a pass-through. It happens in transit. It is now my application's responsibility to store this data somewhere, maybe in a database or in the file system. But what's important is that my application doesn't have the encryption key or the decryption key. Vault does. So in order to get this plain text value back, in order to get foo back, we have to pass this ciphertext along with our Vault token, our authentication, back to Vault. So let me show you where that works, is that we have to write to transit decrypt. So previously we wrote to encrypt. Now we're writing to decrypt with the name of the key. And we pass in the ciphertext. Since this is already base64 encoded, we won't have to encode it again. So I'm just going to go ahead and copy and paste that. And now I'm going to get back base64 encoded plaintext, which you can already see is very similar to what we had up here. But I'll go ahead and just prove it to you. So echo pipe base64 dash decode, and it's foo. So again, probably not feeling super secure now, but we have an encryption service. We have a thing we can use for encryption as a service, and our applications don't have to implement AES or GCM or CBC. It's just there. Now, if you're familiar with those different cryptography suites and the different algorithms, you can configure Vault to use them. Those are options that you can pass in when you say create this key or create this key ring. But one of the cool things about Vault is that we can upgrade this key ring at any time. And when we upgrade that key, we get a new encryption key. Again, the application doesn't know about that. But we have old data, and that old data is encrypted with that old key. So it's lost forever, right? No, Vault actually keeps a key ring of all of the previous existing encryption and decryption keys. So whenever your application goes back to Vault and says, hey, I have this ciphertext, please decrypt it, Vault will say, hey, sure, here's the plaintext back. But then in the background, it'll upgrade that encryption key to the newest version. And you can actually get analytics data back from Vault for your compliance officers to be able to say, yes, all of our data is encrypted with a key that is at most no more than 2 weeks old. pretty cool stuff. Let's talk about dynamic secrets now. So this is all static data, right? I typed in plain text data. But what if I want to do something more dynamic? Well, I'm going to go ahead and mount the new unified database backend in Vault. Previous versions of Vault prior to 0.7.2 had individual backends. There was a Postgres backend and a MySQL backend and a Microsoft SQL backend. And we've unified those into what we're calling the unified database backend. This helps because you can just think about it as a database. You don't have to think about the implementation details of Postgres, for example. And now because I'm terrible at typing, I've cheated and created these scripts ahead of time, but I'm going to show them to you. So the first one here is a Vault command that is going to set up the connection to a Postgres database. This Postgres database happens to be running on localhost, but that could have been like an RDS URL or a pointer to database.service.console or something. So I'm telling the database backend to use the PostgreSQL plugin. I'm telling it to connect using my local connection and connect to the database named MyApp. And I'm telling it that the only roles, we'll talk about roles in a second, the only roles that this backend responds to are read-only. And a role is just a named, basically SQL query. So I'm going to go ahead and run this. Set up PG connection. Perfect. So now I have configured Vault to be able to talk to my local Postgres cluster. Now I have to tell Vault how to create users. So Vault has some really basic understanding of how to create a user, but it doesn't know what permissions you'd want to grant to that user. Perhaps you want to grant read-only. Perhaps you want to grant read, select, update, but not delete. Or perhaps you want to grant delete only. So Vault has no idea how you'd want to generate those permissions. So what we do is we give you the ability to give us the SQL that you want to run. So you can still copy and paste from Stack Overflow. Don't worry. Let me show you what that looks like. So cat setup pg role. So here, this is really the one I didn't want to type out. Here, we create a role named read-only. So this part of the URL up here, this read-only part, is the name of the role. I'm telling it that it belongs to the database name PostgreSQL, and I'm giving it a creation statement. That creation statement is to create a thing with a password that's valid until an expiration, and then give select, which is read-only, on all of the tables in this database. So what are those curly braces in there? Well, name, password, and expiration are actually filled in by Vault dynamically at runtime. So those are interpolated. Vault's going to generate a high entropy UUID for both the name and the password. And then, as I said before, these credentials have a lifetime. So Vault uses Postgres' valid until clause to make sure that these credentials expire after their lifetime. So I'm going to go ahead and run this, set up pg role. Cool, now that role is written. And now, to generate a database credential, so all of these steps would have been done by like an operator or a DBA in advance. As a developer, I'll put on my developer hat. I need a Postgres credential so my app can talk. I just read, Vault read, from database creds read only, if I can type. And I get back credentials. And this is a real username and password that can connect to this database that is assigned to those permissions. And let me prove it to you. So I'm going to go ahead and log in to the Postgres database here. And when I list the users, you can see that, of course, it's down on the bottom of the screen. You can see that there's a V token, which is the username that was created, in my database as a user, and that password is valid until May 18th at 10:38:44. That's 2 hours ago, or 10 hours from now. What's going on there? It starts with a U and ends in TC, right? So this database is configured for UTC time, so that is whatever time from now in UTC. Cool. Questions about that? What's great is that each time, I should leave Postgres. Each time I run this command, I'm going to get a different username and password. So each time I run this command, Vault is connecting to Postgres, running that SQL, interpolating those values, returning back the username and password to me. And you'll notice that these values do have a lifetime. I'm running the Vault CLI, but like you probably don't want to install the Vault CLI on every tool. How many people here write in a programming language that can make an HTTP call? You can interact with Vault, and let me show you. I'm going to use everyone's favorite tool, which is curl. I'm telling you, it's the best thing ever. I am going to curl, and unlike the Vault CLI, I have to pass my authentication in as a header. We use a header for security so that it doesn't get logged in the access logs. So I'm going to pass in my xVault token, which is root. If you remember earlier, I did the Vault auth root. And then this Vault server happens to be running on localhost, so 00, why can't I type 00180-200. The API lives at v1, and then everything else is just what we typed, database, creds, read-only. And I don't know if I installed JQ or not. I did. Huh. Look at that. I typed that right the first. How many people ever got a curl command right the first time they typed it? Man, I'm on a roll. All right. Here, we get back the whole JSON payload, and this is actually what the CLI is getting back. The CLI is just an HTTP API wrapper with a little bit of caching for us locally for like the credentials. Notice that that's a real username and password. So if your application can speak HTTP and parse JSON, you can interact with Vault. If you write in a programming language that cannot make HTTP requests and cannot parse JSON, we're hiring. Questions? Cool. Let's talk about non-databases now. I'm going to go ahead and mount the AWS backend. AWS. In order for Vault to generate IAM credentials, it has to be given a user, an IAM user, that has enough permission that is the superset of the permissions it could ever grant. So what does that mean? Well, that means you're going to have to give Vault a privileged IAM user. Probably not a root user, but it has to have the ability to create other users, and it has to have the permissions that you're going to grant to any of those other users. Because Amazon's permission model, rightfully so, won't let you grant permissions to a sub-user that you don't have. That would be a privilege escalation, right? If I create a user that can create other users, but I don't have permission to launch instances, why should I be able to give them permission to launch instances? So a lot of times this is off-putting to people who are getting started with Vault. They're like, I don't want to give that root credential. That's not one. No, it's actually better because every request and response in Vault is audited. So instead of giving this to a human who you're going to rely on clicking buttons in the UI, you have a full audit log that shows you every request and response that happened in Vault. So you have an entire history. So let's go ahead and configure Vault. There's a setup AWS Connection thing here. And I've cheated because I have these in environment variables already so that you don't get to see them. But my access key, my secret key, and my region are all configured in an environment variable. All I'm doing is I'm giving these to Vault, and Vault's going to store them encrypted in its configuration. So let me go ahead and run that. Boom, I'm now configured to talk to AWS. And Vault actually validates that connection the same way it did with the database. So when I ran that query, it actually tried to make a dummy connection to the database to validate my credentials. So I know my AWS credentials are valid. Similar to the database backend, we have to tell Vault how we want it to make IAM users. Which permissions should these IAM users have? Should they be root users? Probably not. Should they have the ability to launch C43XLs in all regions? Probably not. Well, instead of Vault building its own really complex policy engine, Amazon already has one. It's called IAM policies. And we have one here. And apparently, I'm not able to open. There we go. We have one here. So this is a really basic Amazon IAM policy that gives whatever user I create the ability to manage all IAM resources. Pretty straightforward. So let me go ahead and upload this now. So I'm going to create a role in Vault. That role is going to be called user. And that user is going to be attached to that policy each time I generate one. So let me show you how to do that. Vault write AWS roles user. So I'm creating a role named user. And I'm passing in the policy. And that policy is that file on disk. And Vault actually reads from disk if you pass in the @ sign. So that reads a local file from disk by using the @ sign. So now what we've done is we've connected to AWS. We've told Vault that whenever a user asks you to create a role named user to assign this policy to that IAM user. So just like the AWS, or just like the database backend, now all we have to do is read from AWS Creds user. And this will take a second longer. You notice it wasn't as fast as the database connection. And that's because it actually had to go from my instance, talk to Amazon, run a query, run a request, get the request back, parse it, and put it in the thing here. And you'll notice that if I run it again, it'll take a second or two. But notice that I'm getting back a different access key and a different secret key. These are valid for a really long time. How long is 768 hours without Googling it? Perfect, 32 days. So 32 days is a really long time. I think 30 seconds is better. So I'm going to go ahead and write AWS Config Lease. And I'm going to say that this lease is 30 seconds and that the lease max is, we'll do 5 minutes. What does this mean? Well, in Vault has this really cool leasing model. Meaning, when you generate a credential, that credential is valid for the minimum amount of time in the lease, in this case, 30 seconds. That credential can hit a TTL. It can go back to Vault and say, hey, I'm still using the credential. Hey, I'm still using the credential within that 30 seconds, and it resets the timer. However, at the end of 5 minutes, whatever the lease maximum is, that credential is revoked. Doesn't matter if it's still in use. Doesn't matter how many times it's been renewed. What this allows you to do is this allows you to tell your compliance officer that I guarantee any AWS credential that is unused is only valid for 30 seconds, and any one that is currently in use will live for at most 5 minutes. How many people can say that right now to their compliance officer? Exactly. So I'm going to go ahead and write this. But this is not proactive. This is not retroactive. This does not go back and change those ones. So those ones that were valid for 30 days are still valid for 30 days. And those were on the screen, and I'm sure someone tried to write it down because you're all dishonest people, right? I need to revoke those. Shit, what do? They were on the screen. I shouldn't have done that. It was in my notes. All right, I'm just going to go ahead and revoke everything under the AWS prefix. And what this is going to do is this is going to iterate over Vault's internal database and make an API call to revoke those credentials. And you'll notice it took a couple of seconds because we generated a few credentials, but that just revoked all those credentials I created. So if someone did write it down and you tried to access AWS right now, you would not be able to do so. We can do the same thing with Postgres. So let me just show you real quick. Postgres-u, PostgreSQL, or Postgres. So we have a user in here, or a couple users in here, right, because I ran that command a few times. It's time that they go away. So vault revoke -prefix database. All they're gone. And I could actually restrict this to like just the read-only creds if I wanted to. So it's a prefix match. But let me run that same command again. Postgres, du, all gone. That simple. No Postgres commands, no fancy things. And again, that command I ran, it's an API call. So you could have a service do that for you. You could literally create a button that says, oh shit, and someone could click it and it would revoke everything. How cool would that be? I'm sorry for swearing. I think it was funny though. All right, one of the last things I want to show you is Vault acting as a certificate authority. Now, this is complex. Vault masks as much of it as possible, but there's a lot of complexity in setting up a CA. You do have to have an understanding of like X509 and TLS and basic understanding. So I have decided that you don't need to know that because I wrote it all in advance in this magical setup PKI script. But what this is doing is this is configuring Vault with a bunch of stuff. It uses an internal CA, but we could use an intermediate CA or our own root certificate. It configures the crills and the URL endpoints, et cetera. It's a bunch of stuff that is, right now, I'm throwing away. And all of this code will be open source on GitHub at the end of the talk as soon as I switch it from private to public. So you'll be able to look at this. Don't want you to get bogged down in that too much, because the nice thing about Vault is that it's a one-time config. So I run this command for setup PKI, and it's done. I don't ever have to think about it again. And I've written a number of blog posts on how you can codify your Vault policies, so how you can integrate this with like CI or CD, so that you can use source control to manage these Vault policies instead of running commands locally. So now I've set up my PKI infrastructure, and I'm going to issue a certificate. Well, how do I do that? Well, I write to PKI issue against the role named my website, and I give it my TLD, or my common name. So this could be like, my app 1 .node.internal or .company.rocks or whatever your internal TLD is. But in this case, I've configured it for example.com because cool. And we get back a certificate. This is a certificate. And then there's the issuing CA. And then there's the private key, starting right there. And we get back a serial number and stuff as well. One second. So all of this is an API request away. So you don't have to write your certificates to disk. You can actually load them in memory so that even if an attacker gains access to your file system, they would not be able to read these files. They would have to dump your core process in order to get these credentials out. And again, this is all an API call away. So you don't have to use the Vault CLI. You can use the JSON parsing. Question? Sure. Alternative name is another option. So is SNI. There's a bunch of, the PKI backend is very configurable, so I'm just using the most basic example here. But if that's outdated, I will research that and update my demo that I wrote last night. All right. How much time do I have?
How much time?
Yeah, how much time do I have?
9 minutes.
OK, I'm going to do one more. This is the bonus. All right, I'm going to mount the TOTP backend. Again, this is the one that's going to generate MFA or 2FA codes. And there's a, I'm going to just cat. I built this in advance to save some time. So this is an OTP auth URL. If you've ever scanned a barcode with Google Authenticator, this is actually what that looks like. That barcode is not some fancy magical thing. It's actually just an encoded URL with like a secret and some metadata. So this is what one of those looks like. So obviously Vault is a CLI tool. You can't exactly scan a barcode easily. But you can usually get these TOTP URLs if you click like, I can't scan this, or this is not available to me. What I'm going to do is I'm going to write this OTP URL. TOTP keys. So this is my demo key. I'm going to write OTP URL.txt. I'm going to write that key. So what that did is it told Vault, whenever I read from the key demo, execute that TOTP authentication URL. So I'm going to just read from TOTP code demo. That'll get me the code. And I get back a 6-digit standard TOTP code. And I don't know where the timer is, so there we go. Hey, perfect timing. I get back another 6-digit TOTP code each time I read from this. But notice that there's probably like a 30-second TTL. That's usually the default. So it's going to keep it, it's going to keep it, it's going to keep it. And then if I keep talking for like another 15 seconds, eventually I'll get another code. But again, this is basically replacing something like Google Authenticator or Authy. And yes, this is not a pretty UI. It's not a mobile app. So it's probably not the best to replace for a non-technical user. This is best for, I don't know, maybe enabling MFA on your root AWS user. Because you don't want to store that in like Authy, because you might have multiple operators who need access to those root credentials in the event of an emergency. But if you put them in Vault, you can grant access based on the permission model, but you also have a full audit trail. So you know whenever Jamie accessed the root account credentials because she made a request to Vault. Flip it around though, Vault can actually act as an authenticator. So I can write to a key. So instead of writing a URL, I can write to a key and I'll name it my app. And I'm going to pass in the generate flag. So this tells Vault that I actually want it to generate a TOTP URL for me. The issuer is required by the spec, so this is just going to be Vault. And the account name is going to be my email, seth@hashicorp.com. Whew, we got back a bunch of stuff. So we got back what looks like the standard OTP URL, but then we also got back a barcode. Doesn't look like a barcode to me. Well, that's actually a base64 encoded barcode. So let me show you what this looks like. So I'm going to copy this to my clipboard, and I'm going to jump down here onto my local laptop. Shove that up there. So I'm going to decode that thing that I just typed, and then I'm going to pipe it to a file. So this will be QR. It's a ping. base 64. Okay, and now I can actually open this URL, and look at that. There's a barcode. So I'm going to just make this a little bit bigger, and I'm going to open up 1Password. How many people here have ever used 1Password? This is not an endorsement for 1Password. It just provides a really cool visual. So I have this vault here, and 1Password actually has the ability to generate what are called 2FA codes, not MFA codes, because MFA requires a second factor, like another phone, whereas 2FA just MFA just requires like multi-factor, meaning more than one password, or in this case, more than one login token. So I'm going to go ahead and make a login in here, and I'll call it Vault Demo at OSDC. My username was Seth at HashiCorp.com. And then down here, I'll create an MFA section. And this is a one-time password. And this one-time password brings up this really cool code scanner. Y'all ready for this? Boop. And you'll notice that that looks very similar. Again, I told you the URL is just encoded. I'll click Save, and that's an MFA code. I don't know why it's there twice. That's an MFA code, just like you would use with like Google Authenticator. And it's going to expire every 30 seconds. So I'm going to grab this to my clipboard real quick. I'm going to run back over to Vault, and I'm going to write TOTP code my app code equals that. I'm on the wrong thing. OK, cool. I'm valid. It's true. It was valid for 30 seconds. But if I run back over here, I'm about to expire. OK, I'm expired. I don't know what the actual drift is on this, but eventually this will be untrue. It's probably like a 60-second drift, but if you're familiar with the TOTP algorithm. So here, you can build your own two-factor authentication without writing any code. You just write some curl requests. OK, now I have 3 minutes for questions. That's the end of my demo. I hope it was worth it. Thank you.
Yeah. So how about some questions? All right.
That was super cool. Thanks. How easy or difficult would it be to make it so that the user needs to pass two-factor authentication before they can use the Vault CLI or whatever?
Yeah, so the question is, how do we enable two-factor auth on the Vault CLI, authenticating to Vault itself? So Vault authentication isn't something I really covered here. I just authed as root. If you're enabling like LDAP or something login, the user would actually log in with their credentials. So let me show you real quick. Vault auth enable like user pass. This is just basic username and password. So then I can Vault write auth user pass user Seth Vargo password equals banana. This is like Vault's internal secret store. And then what happens is I can auth as that user. So Vault auth dash method equals user pass. It'll prompt me for the username, and then it'll prompt me for the password, which I didn't type right. And now I'm logged in as that user, and I actually can't do anything. I'm just assigned the default policy. So if I try to like write to secret foo again, I'll get an error. Now, adding 2FA to that would be easy. We can probably do that because of Vault's internals. Adding 2FA to something like the GitHub Authentication. The way the GitHub Authentication works is we map your policy to your teams, which is really great because GitHub becomes your source of truth. But in order for you to log in, you actually provide your GitHub API token, not your username and password. So there's no like 2FA mechanism there. Other questions?
Come on. Okay.
So what happens after a server reboot? How do I get Vault to start up?
Great. So one of the things I papered over in this talk was something called the unsealing process in Vault. So Vault really obeys this principle called like no man, which means no one person should have complete access of the system. And the way we do that is by generating these things called unseal keys. And unseal keys are shards of a master key that are decomposed and given to a number of trusted users, such that a subset of those users can come together to regenerate the key. It uses something called Shamir's secret sharing algorithm. So when the Vault reboots, or when it first starts up, a quorum of those unsealed key holders have to enter their key in order to make the vault active. I did that in advance for this talk because I didn't feel like typing. One of our enterprise features, one of our paid features, is auto unsealing of the vault, where you can use a hardware security module to actually do auto unsealing of the vault, so that, again, no one person, but a machine can actually auto unseal the vault. But normally, you run Vault in high availability mode, so that even if you lose a server, the rest of the servers can pick up.
So I saw down there's another question.
Are there any ACL implemented in Vault? So I can have multiple users with different read and write access to different credentials?
Yes, everything in Vault is ACLs. In this demo, I just used a root ACL, which is everything permission. I could give a 2-hour talk on Vault's policies, and I didn't want that to confuse people. But there's a really, really, really good policy engine in Vault that lets you explicitly give or deny access to different paths. Everything in Vault is path-based. So you can say that, one of the things that we do internally is anyone in the developer's team on GitHub has the ability to generate IAM credentials in staging. You can actually build those really complex policy workflows. I forgot to show this. This is a real thing. This is vault.hashicorp.rocks. You can hit this on your URL. This is not open source. This is our enterprise UI. But one of the questions that I always get asked, I'll preempt it, is there a UI? And there is, and that's one of our paid features. But this allows you to do replication, which is another enterprise feature between multiple data centers. The policy manager's in here. And then there's also like a bunch of stuff with response wrapping, which we haven't talked about.
Okay, another questions?
Are there any cool wrappers for program languages like Golang?
Are there any cool
Wrappers to client libraries to hide the REST API?
Sure. So at HashiCorp, we maintain 3. We maintain the official Go one, the official Ruby one, and the official Rails one. The Go library is actually inside the repository because, and I always thought this was really cool, the CLI, those Vault commands, consumes the Golang API that we publish to people. So inside here, there is an API package. It's right at the top. This is the API. However, if we take a look at the CLI, which is under command, what's a good one? Auth. You'll notice that it imports the API package. So we actually super dog food. The API, the Golang API that we're giving to you is the API that we package with the CLI to issue those commands. For the Ruby library, it's just Vault Ruby, so Vault-Ruby. And then there's a Vault Rails one, which integrates with Active Record. If you're looking for client libraries, though, you can head on over to vaultproject.io. On the API tab, there's a whole section of client libraries. So we have the official ones, which I mentioned, the Go, Ruby, and Rails one, and then there's Ansible, C#, Clojure, Elixir, a third-party Go one, Haskell, Java, Kotlin, Node, which is official on Android now, PHP, Python, Rust, and Scala.
Really cool stuff. Thank you.
So further questions? Okay, so really great stuff. Cool demo. Thank you very much, Seth.
For those of you that didn't hear, there are stickers up here. They are all free reign. I have Vagrant Packer, Consul, Terraform, Vault, Nomad, HashiCorp, Rainbow, and HashiCorp. So if you want stickers, please come up and take them. Otherwise, I have to take them back with me. Thank you.